time too.
That's right. Okay, Rick, you're up. And share my screen. And welcome to everybody who is on YouTube. If you're joining in from there, this is the Kingston Center's regular meeting. Did we lose Rick?
Rick's not here.
We lost Rick. Well, okay, I guess this means, Laura, you're up.
Rick's back.
Oh, Rick's back. Rick's back.
Rick's here, yeah.
Okay.
Man, I just ran out to check the sky.
There is no sky in a meeting, okay? That's
Yeah. Well, ideally, I'm observed. You know, the telescope is doing some observing for me, but the forecast has been rather poor. Last night, I started everything up and went to bed, and the telescope was observing all night, and it was supposed to be relatively clear all night, clouding over in the morning with then showers starting. Fortunately, I woke up at 4 o'clock in the morning, noticed that it was cloudy out, checked the satellite. Sure enough, it's going to stay cloudy. So I closed up the observatory, and the next time I woke up, it was raining out. If I hadn't woken up at 4 o'clock, my telescope would have been full of water. And then this evening, there was supposed to be some clear skies, but looking at the satellite picture, I'm not seeing anything very promising. So anyway, we'll get on to the sky this month. Everybody's interested. November. How do I do this? Oh, here we go. Upcoming events, quite a lot going on this month. The 13th to the 15th is the AAVSO annual general meeting. I neglected to register for that earlier, and I noticed they have a deadline of October 26th to register for the meeting, which seems kind of dumb. However, I missed that one. 20th of November, I see that the Queen's University Physics Department has started up their colloquia again. So they're doing them on Zoom. So on the 20th of November, David Morrissey from Triumph is giving a presentation. 21st of November, the BAA historical section webinar. I don't see any indication as to what its content is, but if you're interested in the history of astronomy, it's a good one. 27th of November, another physics colloquium, Laurence Perot-Levasseur from University of Montreal. And no topics given for these colloquia yet. 4th of December, another one, Eric Xiao from Florida State University. 5th of December, the BAA Christmas meeting webinar. 9th of December, our next regular meeting. And then throughout the month, every Wednesday evening, we have our Kingston Center Zoom socials. And Queen's University Observatory is doing a series of podcasts about fast radio bursts. You can go to their website and there's a link there to listen to them. I haven't had time to listen to one yet, but they do look like they'll be very interesting. The two local dark sky areas, no events scheduled until spring. So you're doing socially distanced observing on your own. There seems to be apparently circles are painted on the pads to keep people separate. You should wear a mask. And my personal recommendation is don't share telescopes. People pick up germs off of eyepieces and stuff right on their face. The hours of nighttime, you can see we're getting to almost 50% of the day is dark astronomical darkness, certainly nautical darkness, and better is over 12 hours of nighttime. The moon this month, new moon coming up on the 15th, just a few days. So this is good deep sky imaging and observing time. First quarter moon on the 22nd, full moon on the 30th, and last quarter moon on the 8th of December, just the day before our next meeting. Now, I don't know how well this is going to show up for you guys. I hope this works. I've lost my notes here. Here we are. Okay. So on the 12th of November, in the dawn sky, before sunrise, we have Mercury and Venus and the moon. And of course, that'll be a fairly nice crescent moon. And by the following day, over the next couple of days after that, the 12th and 13th, the moon will pass by the two planets. Be quite attractive. The evening of
the
yes,
date again on that?
that's the morning of the 12th. But I think I show it again on the morning of the 13th and on the 14th. So we'll get to the better ones. Oh, there's the North Torrid meteor shower. Max is on the 12th, and it's quite a minor shower. You probably won't see more than a few meteors, maybe up to 10 per hour. However, the shower is known for producing a high percentage of fireballs. So it's probably a good time to get out, do some wide field imaging, and you might pick up some fireballs going through your pictures. On the evening of the 12th, I guess that's tomorrow already, Jupiter and Pluto are quite close together, about 40 arc minutes apart. And interestingly, I mean, if you've got a telescope big enough to see Pluto, which is down around 14th magnitude, 14.4, so it's 4 million times fainter than Jupiter and in the same field of view. So that'll be kind of a unique observation. This would be the morning of the 13th. So you have a slightly narrower crescent moon lying between Venus and Mercury. Gets prettier and prettier. And then on the 14th, you can see the moon has passed by, but on this morning, the moon will be a very, very old, extremely thin crescent, only 17 hours before noon. And so you have to get out there sort of just a half hour before sunrise to see that. However, Venus and Mercury will both be, well, Venus is very bright. Mercury will be quite bright. And the two of them point almost exactly at the moon, so that will help you find it. On the morning of the 17th, the Leonid meteor shower maxes. The radiant, I'm not sure how common, the radiants tend to move as the Earth moves along its orbit. And I'm not sure, but it seems to me that the Leonid radiant moves further and faster than most of them do. It starts off near the tip of the head on the 10th, and by sort of a couple of weeks later, it's moved well into the body. But most of the meteors will be coming from a point in the head of Leo the Lion. And it's a decent shower, 10 to 15 per hour. They're very, very fast meteors. Every 33 years or so, it gives major outbursts of up to tens of thousands of meteors per hour, but not this year, we don't expect. On the evening of the 18th and 19th, There's be a very attractive crescent moon near Jupiter and Saturn and Pluto, if you can see it. On the 18th, it's down and to the right, and then on the 19th, it's basically to the left of Jupiter and Saturn. So it'll be quite attractive. And that's about it. I didn't find anything exciting happening in early December. Any questions? Anybody
Great.
there?
Great, Rick. Thanks. Hopefully everybody can get out and do some observing. Even though they're calling for snow. That's okay. It won't happen. Okay, next up is Lori.
Unmute. Share screen. Okay. Over. There we go, slideshow. There, does that look good?
Looks good. Yes.
Okay.
Very good.
So I decided to do this talk because I decided to do a certificate in geological sciences through St. Lawrence College. I'm taking online courses, and right now I'm doing one in mineralogy. And one of the things we're required to do is to find news reports about things related to the field. And I found a couple that were really interesting that sort of bridged mineralogy with, astronomy. So then I decided to expand it to kind of figure out how old things are in the universe and in our local environment. And also, how do we know how old these things are? So the first view I've got here is from the Hubble Ultra Deep Field view of the universe. And here we see galaxies that that are only, say, 1 billion light years away from us. And we're looking back in time to galaxies as they would have appeared 13 billion years ago. So the first question is, when did our universe form? And the current number is about 13.77 billion years ago. And we know this from looking at the cosmic background radiation, which is the afterglow of the Big Bang from when the universe first became transparent. And it's no longer high energy photons. Because of the expansion of the universe, everything is redshifted down into the microwave. So this age is dependent on models about, and on the expansion rate of the universe and that. So, it's not written in stone. So then the next question we can ask is, okay, now we've got a universe. When did galaxies and the first stars start to form? And this answer comes from looking, way back in time in images like this. And the oldest galaxy that's been found to date was found by Hubble. And so this is, sort of a view. I've given the link down at the bottom here. And we have the Hubble Space Telescope looking at an object that is about, it's looking back in time. And this object is about, appears as it did 13.4 billion years ago. And so that's only about 400 million years after the Big Bang itself. So that means that galaxies formed very early on in our universe. So in the paper, they talk about the stars being only about 40 million years old on average in this galaxy. And the light's been traveling, as I said, 13.4 billion years ago. But because the universe has continued to expand, since that light left that galaxy, its actual true distance is more like 32 billion light years. I can't quite see my whole slide here. So, so we know galaxies formed a long time ago. And the way they figured this out, I actually found quite interesting. So to estimate the distance to something, the gold standard is the spectral Doppler shift, because the universe is always expanding, and the further away an object is, the faster it's receding. So you can calculate this thing called a redshift parameter, Z value, that is, it's very simple calculation. You just take the difference between the redshifted value and the original value as if there were no motion, and you divide it by this original value. And so for this galaxy, this number is huge, 11.1. And what they actually looked at was this thing called the Lyman limit, that's at 91.2 nanometers. And so that puts this light in the ultraviolet. And this is interesting from an atomic perspective. What it is this is the energy required to take the electron that's in a hydrogen atom and completely bounce it off that atom. So it's completely gone. And you notice, so that's from the ground state to complete ionization. And so these lines here are from higher states down to the ground state, and they all start to pile up. So if we take this number and we put it in this equation, what we find is with the Z number that they were given, that the wavelength that they're actually looking at is 921 nanometers, and that's on the other side of the visible spectrum. So it started out as being ultraviolet, but now it's in the near infrared. And the Hubble Space Telescope was able to do this with their infrared spectrometer because this is within the range of that instrument. So this is a very obvious line, and so that was how they were able to do this and date this galaxy. So obviously galaxies formed a long time ago. What does that have to say about our galaxy? Well, we can date our galaxy by finding the oldest stars. So here's a picture of the Andromeda Galaxy. This was taken by the Swift Space Telescope, and this is in the ultraviolet. So these are not the kind of stars we want to look at to date a galaxy, because these are hot young stars that have very short lifespans compared to the smaller stars. So even our own sun is not going to work, because it, as a yellow dwarf, it's only going to live about 10 billion years. But when you look at your red dwarf stars, they live a very long time. So something with a quarter the mass of the sun is going to live about 1 trillion years. So there's a number of very old stars in our galaxy, and I'm only going to talk about one which has been nicknamed the Methuselah star. And it's actually pretty close to the Earth. It's only 190 light years distant. And that's close enough that you can get a pretty accurate distance by parallax. So that's where, you know, at one time in the year, you know, the Earth is over here relative to the sun, and 6 months later it's on the opposite side, and you see that position of that star shift a little bit relative to the background stars because it's close. Relatively close. And the thing that's interesting about this star when you look at the spectrum is that the predominant lines in the spectrum correspond to hydrogen and helium and nothing else. And that's because this sun has what we call very low metallicity. And the term's a little deceiving because it actually refers to anything that's above helium on the periodic table, because the initial Big Bang generated, you know, mostly hydrogen, then helium, and then trace amounts of other things. Anything, trace amounts of lithium, but nothing bigger. So when we look at this star, it has very little higher elements like oxygen and carbon, but our sun actually has about 2%. So that tells us that our sun formed much later, after these heavier elements were made by stars that, you know, reached the end of their lifespan. So we know the luminosity of this star and the surface temperature. And the important thing about this is it's off the main sequence. it's about 0.8 solar masses. So it's somewhere between the main sequence and heading on its way to, being a red giant. And based on models of stellar evolution and how long it would take a star of that mass to reach that stage in its lifespan, it's been given an age of 14.56 billion years, which is actually older than the age of the universe. But that's okay because, these are based on models. Both numbers are based on models. And they have error ranges. So that puts it in within the range of the age of the universe. So this means that our galaxy formed very early on, shortly after, within probably a few 100 million years after the Big Bang. So what about our solar system? And this is where I get into all the stuff that I was covering in my mineralogy course. So one of the really good materials we have for dating rocks is zircon. And this is the, where's my mouse gone? This is the formula for zircon. And it's a really nice, robust mineral. It melts at a very high temperature, which is actually hotter than a lot of the magmas that we have. And so it can last for a very long time. And some have been found in the Jack Hills of Australia that are about 4.4 billion years old. Here's one from the Apollo 14 mission that's been dated to 4.5 billion years ago. And meteorites have been dated to about 4.56 billion years ago. So the meteorites are kind of, the benchmark to give us an idea of when our solar system started forming, when things started clumping together and forming larger bodies. And what this suggests with zircon here from the Apollo 14 mission is that the cataclysmic event with the two bodies crashing together to form the Earth-Moon system actually occurred very early on in the evolution of the solar system. And then this number here, 4.4 billion years, suggests that the crust of the Earth actually started forming only about 100 million years after that event, which is actually a lot earlier than people initially thought. So that's quite interesting. But I wanted to know also, so zircon's being used to date things. I wanted to know how that was actually done. So the thing about zircon is that the zirconium atom is readily substituted for uranium, and it's typically about 0.1 to 0.5%. So that's that's a fairly significant amount, and the uranium fits in beautifully. But lead has a completely incorrect electron configuration, and it just won't go in there. It won't interact properly. So when you look at a young zircon, they have virtually no lead in them. So what happens when uranium decays is that uranium-238 turns into this isotope of lead, and it has a half-life that's about the same length as the age of our solar system. So when you look at these meteorites, what you find is about half the uranium has decayed to lead. But the nice thing about uranium is there's another isotope that decays to a different lead isotope. And oops, how do I go? How do I go back? Okay. So this one actually has a half-life that's quite a bit shorter. And so when you're looking over the age of the solar system, what you'd find is only about 1.5% of the uranium would be remaining. But the nice thing about this is you can measure all of these isotopes, and you get two independent measures of the age of the crystal from one. So yeah, it's quite interesting that the Earth was starting to harden so soon after the large body smacked into it. So then the last question I was interested in was where and when did the material that formed our solar system arise? So all of these heavier elements would have had to have been synthesized within stars. And the way that they're starting to get at these questions is to look at meteorites. And they often contain, certain meteorites contain silicon carbide. And they're very resilient. They persist for a very long time. And they provide clues to the origin of the elements. So one paper that I looked at, what they did was they measured the ratios of contaminating nitrogen and the ratios of the isotopes. And then down here, I think that's the carbon isotopes. And based on predictions of what happens when stars, blow up, they tried to determine where did these particles come from. And they found that some came from supernova, like these guys here. These ones here looked like they came from nova, from material falling on, say, a white dwarf. And then these are other things that were sort of blown off stars. So it looks like the carbon that is present in our solar system is coming from a variety of sources. And the last thing that I wanted to know was, how old is this carbonaceous material? So there's been studies done on, again, on the Murchison meteorite, looking at the silicon carbide. And as it's floating around in space, it's constantly getting weathered by cosmic rays. So this is a totally different way of dating. Basically, they're looking at how much damage has occurred to these silicon carbide pieces. And they found that about 60% of them were between 4.6 and 4.9 billion years old. And what this suggests is that these stars blew up shortly before our solar system formed. And it's likely that, these events were what actually caused our solar system to start forming. So when the blast wave, say from a supernova, hit the gas and it started to compress it, and then maybe that's what started, this particular cloud started to collapse and then form our sun and everything else in it. But the interesting thing is that the other 40% are older. They're up to 7 billion years old. So obviously there's material mixed in that came from stars that had blown up billions of years before the ones that actually caused our solar system to start collapsing. So I'm done with, and that is my sort of march through the age of our solar system. And I will stop screen sharing. And does anybody have any questions about that stuff?
Science. Old rocks. All right.
Yeah, nothing in my collection is that old. Probably I'm looking at 1 billion or 2 at most.
Some of the questions some of us have wondered for a long time. Thanks for getting some answers, or possible answers.
That was actually very interesting. Thank you very much.
You're welcome.
I have a question, if you don't mind. I read a little bit about supernova and the death of stars, and I know that basically through fusion, you can reach pretty heavy elements, and then until a certain point, and then the star basically will collapse and explode. And can you tell me what is the heaviest element that I can reach through fusion?
Iron. Well, okay, under normal circumstances. Iron, if you look at the energy of the nucleus, then hydrogen's way up, and then you get a big drop when you go to helium. So that's what's powering the sun now. And as you go element to element, carbon, oxygen, nitrogen, all the way down, you sort of reach a point at iron where you don't get any energy out when you stick anything more in that nucleus. So it's at the minimum. And then as you start to go up the other side, you get to, I think uranium might be the largest naturally occurring. And you have to actually put energy in to generate those atoms. So that's why the nuclear reactors where you get energy from fission work.
Okay.
So it's kind of like, fusion's coming the one way, going down to iron, and fission's coming from the heavy elements, again, down to iron.
Okay.
And because those higher elements take a lot of energy to form, it really takes cataclysmic events to form them. And I'm not totally up on the latest about how they form, but I think maybe somebody else can chime in. But I think it's not just supernovae explosions that are thought to form a lot of the heavy elements. I think it's I can't remember. Does anybody know where?
I think there's a beryllium and lithium and a few other things of that size that are created just purely by the impact of particles post-explosion. I seem to recall reading that. So there's a lot of them that are made just because they're being forced together just through the kinetics of just after a supernova and whatnot.
Yeah, and I know with the way things happen in stars that those elements really aren't formed to any appreciable amount through fusion within the core of a star. It, with the reactions that are going on, it just skips right over those elements. And I think there's something about neutron stars and stuff hitting the surface of neutron stars that tends to give us a lot of the more exotic, heavier elements.
Okay. Thank you.
That's awesome, Lori. That was great.
I am a molecular
Really enjoyed that.
I'm a molecular biologist, so it's a bit, I'm not an expert.
Well, that was a fun
Great.
talk.
Thank you so much.
You're welcome.
Okay, next up we have Kevin with Trifecta.
Howdy, howdy. Some of you may have share screen. Come on. Some of you may have read about this earlier in the month in October. Nope, there we go. We went on a road trip to get the heck out of the house because it's been driving us nuts. So we decided to drive up to the 3 different dark sky observing sites within the Kingston Range. So right now, hopefully, I'm showing an image of a Google map from Napanee to the LNA dark sky viewing area. Can Kim Nolan confirm? All right. So it's 27 minutes north. And from Kingston to Napanee, probably another 20 minutes or so, depending on how fast you drive. And once you get there, this is the one that basically Terry Dickinson was the moving force to get together with Lennox and Addington County to create. And it's been there for a lot of years now. And when you get there, you have to take an obligatory selfie and say, hello, I'm there. You have to take pictures of the obligatory signs. Oops, I tried to expand that and I don't think it worked. So I'm just going to back away and reshare because that did not work like the way I thought it was going to work. So let us try that again. Share, Kevin acting silly. And there's a nice little sign there. When you're driving north on 41 from Napanee, you'll see the notices. So it's fairly easy. You just have to slow down and watch for traffic. The observing pad itself has an interesting little black bird, raven, crow, whatever you'd like, facing and pointing towards the north. And I also forgot the obligatory Terry Dickinson plaque, which you must stop and take a picture of. Since it first opened, they've opened up a secondary parking area. And the day that we went there, 3 old white guys drove in with Corvettes. Oh my God. This is the observing platform itself. As Rick mentioned, there are social distancing circles on there where you're expected to set up and keep out of each other's way. And that's looking back across the whole pad. So it's not really that big. 1, 2, 3, 4, 5, 6, 7, maybe 8 circles on their tops. We don't participate in an active way with this at all. There are others, including some of our members, who do. I'm not sure if it's how organized it is on behalf of Terry, on behalf of LNA County. It's always been a little nebulous. Anyways, is that the last picture of this bunch? Yes, it is. So let us go over to the continuing road trip, and we drove north. And so we went to a place called Nirvana because we've never been there before. And Nirvana is not being shared on that screen. So let me share on this screen. An abandoned Ontario Ministry of Natural Resources airstrip. And can we actually see that whole thing? Can I shrink that a little bit? There we go. So again, from Napanee, you drive north on 41, past the LNA Dark Sky site, past Highway 7, past the wonderful suburban area of Northbrook, through the even smaller urban area of Cloyne, and right through the Bon Echo Provincial Park, up to the Addington Highlands. And so that is approximately 72 minutes from Napanee and the 401. We've heard stories about this. Many of you have been there. We have never been there before and wanted to actually see what it was like. So we got there. This is the actual fire number. If you have a GPS unit, I'm not sure if it's going to be accurate, but at least you have a reference point. 19213 County Road or Highway 41. Let's go to the beginning here. This is the airstrip. And it's huge and it's abandoned. I don't think apparently that there's been any regular use of it, and it's only for emergency use. And it's all gravelly, and we got up there and there was a bunch of people there and 3 cars already and ATVers and motorcycles everywhere. Apparently there are also people with guns. Every shiny thing that may have got your attention, I went up and took a look at it, and it's got holes, lots and lots of holes. And this gives you another impression of how big the site is. Lots of trees around there. And oh, look, rifle casings. Yay. Lots of, I'm beginning to wonder if this is a safe place to be at night. We may not think it's a great site, but it's frequently used by people from Ottawa and even Toronto. And given their urban skies, I can see why they want a dark sky. But man, going out there at night, I think you may be taking your life into your hands. Everything I saw that caught my eye had holes in it. Whoa. And we're back to that. And so we were already up in the area. The drive-in was a little bit difficult. Some of the roads were washed out. Don't laugh. And I didn't show you the picture of the Frontenac ambulance that while we were there, we had a little picnic lunch. And an ambulance drove in, and we thought, great, we're going to see an aircraft land here with a medevac patient. A nice panorama shot too. Okay, let's take a quick look at that. And we did some solar observing while we were there. There's the ambulance. And the guys drove up to us and said, hi, how's it going? What are you doing here? And I said, oh, we're just having lunch. What are you doing here? And he says, well, my partner's new and we just wanted to come and take a look at the site, which was basically exactly what we wanted to do. So that was just hilarious, hilarious. Okay, so we've been to Nirvana, aka the Irvine Lake Abandoned Ministry Airstrip. We've been to the LNA Dark Sky Viewing Area. Lastly, we are going to go to the North Frontenac Dark Sky Preserve. And let me now share that picture. And from Napanee and the 401 again, it is approximately 70 minutes to get there. From Kingston, perhaps a little shorter if you went up Highway 38 through to Sharbot Lake and up to there. So its nearest place, urban area is called Ardoch. This again was, oh, look, Malcolm
Your
Lake.
picture's over top of it. How do I get rid of your picture?
How do I get rid of my picture? That would be Mark, and that would be up your control settings, perhaps exit full screen up at the, if you run your mouse to the top of the Zoom window.
RDOC's about 20 minutes, half an hour from our
Okay,
place.
Okay, so
I
Mark's
got rid
all-
of your picture. Now I've got John and Peggy over it.
Okay, so you're missing out on the screen share, are you?
No, it's better.
You'll have to fiddle with your own settings. It's personal to you, the client side. So the North Frontenac Dark Sky Preserve, it would be great if you could camp overnight there. It is approximately 90 minutes from our house because we have to go a long way either way, and we don't like driving that in the dark. This is what it looks like now, in case you haven't been there for a while. They've put up some fencing to block headlights from cars going in and out. And unfortunately, also there is a neighbor right next door. So they put up some more fencing to hopefully stop light from the neighbor. This is the helipad that the Dark Sky Site Observes, North Frontenac Dark Sky Preserve sits on, and it is active. And helicopters can come in here, usually orange air ambulance medevacs, land to meet an ambulance, and they will remotely turn on the landing pad lights. That, I imagine, would be a scary sight if you're not expecting it. This is looking south. Those trees are getting taller. We were there for the opening ceremonies many years ago, 5, 6, 7, something like that. And I swear you could see Lake Ontario, or at least the clouds over Lake Ontario, kind of looking down a mountain slope. Not anymore. Not to say that it's still very nice skies, very, very tall. Malcolm has been there many times doing time-lapse exposures. I'm not sure if anyone else has been there. This is the parking lot. So there's lots of parking, probably 20, 30 vehicles. This is the outhouse. Everybody, yay! Having a privy at a dark sky observing site is just phenomenal. The LNA Dark Sky off of 41 in Napanee area has a part-time privy, a bob, if you will, a plastic one. I'm not sure if it's there all the time. Nirvana, definitely nothing. It only has bushes. So North Frontenac Dark Sky Preserve is one up in the books already. A view from the other side of the observing pad showing you the fences, some benches that are chained down so they don't go for a walk. It's a nice size pad, no social distancing circles on it yet, but I'm sure they're coming. Power, you can hook into power if you have powered scopes. And a nice little plaque. Okay, it was 7 years ago. Wow. And more signs and boulders. I guess that's to stop yahoos from driving their vehicles up onto the observing pad. And another shot of the wall, the parking lot, and the privy way down there. So that's a nice place to go to. We have been there a few times and have done solar observing in the daytime. We have not stayed for a nighttime observing session yet. And that's, again, on the list of things to do if there was a place that we could fall asleep. I suppose if you had a vehicle that you could sleep inside, maybe that doesn't count as camping. I'm not sure. Some nice signage on the road, so you can't really miss it that much. They do have regular events as well.
You could probably stay at one of the parks on 7 and camp the camps in the area. There's a lot of them.
I'm curious, can you actually get in after hours, or do they not shut the gates on you? Or not sure how that works.
The park, I think, does, but the a private one might not, especially if they know that you're out observing.
And this is the fire number again. If you have a GPS and you want to try and find it, 5816, and it's on Regional Road something. I'd have to look that back up on the map. And this is this is so funny. Malcolm has not actually moved into the Harrowsmith area. He's moved into the RDOC area. No. Okay, another poor joke. This regional road here, I can't remember the number of, but it's a turn east at Cloyne, and you'll get there. Or if you're coming up from Sharbot Lake, Regional Road 509 to RDOC, and it's just past that. Okay, that is our trifecta of 3 big dark sky observing sites, dark from the relative brightness of Kingston itself. And if anybody comes across other sites that are of this caliber, where they're safe, easy to find, and don't have bullets around, let us know so we can tell others about them as well.
Okay. Thank you.
May I show one picture that connects to Kevin's talk?
Sure.
It'll be very quick. This was the dedication day, August 29th, 2013, with Terry out at the LNA site. And that's probably a hubcap that somebody left behind at Nirvana. So we all thought that was a very strange shape for the commemorative thing that he got. Anyway, that's all.
Very nice. Thank
Looks
you.
like a tire.
Yeah.
Okay, thank you, Kevin. Next up, we have Hank Bartlett with a surprise.
Well, I'm just terribly sorry about
Oh
the
my
surprise thing. I should have said Hank's sunspot.
You're fading.
I'm fading. That's weird. I have to talk louder or something, or what?
No, you're just fading into the sunspot.
Oh, I thought you meant my voice was fading. Okay, there. Yes, absolutely. Yeah, this is going to be Hank's sunspot, and I'm going to share screen here. It has been host disabled participant screen sharing.
That's my fault. Just a sec.
That's
I
all
have
right.
to first to find you.
I know you're just getting even with me for something.
You're good to go.
I'm good to go. I am good to go. And there we go. And share. And slideshow. Oh, there we go. View, show. And here we are for another edition of Hank's Sunspot. It has been a much better month since last meeting for observing the sun, absolutely. And as it says here, and what might we expect? Well, I'll start off with what we don't want to expect is any more of this 10 to the minus 9 X-ray garbage that happened at the depth of the solar minimum. This is just was pitiful. It was terrible. So this is out, and that's it. So we will go to the 17th of the month in October, and solar observing was picking up. We had a nice sunspot, 12.7. Oh, by the way, Kevin, look at, I made my cursor bigger, much bigger.
Are you sure? That looks pretty tiny to me.
Really?
Oh, wait a minute. You're a man.
You're a funny guy. I was going to make it colored and everything, but I just went that far. Yeah. So 12.776 and nice, good, dark, reasonably sized sunspot for Rosemary to go out and image. I don't think she made it, but it was there. And you notice on the H alpha side, you've got the sunspot doesn't show as much, but there is much of the active region, much more, and solar filaments across the surface. And over on the right-hand side, far right-hand side, by the way, is AR 12.775. There is some plage there. You probably can't see it on this small an image, but as it was rolling off of the solar surface over the west limb. Next is the 23rd. There was quite a few days there, 6 days between observing sessions because the weather has been cloudy. And by this time, 776 has now moved almost to the west limb and is doing well and still staying about the same size. But there is new activity up in the northeast limb area of the sun. But one thing that in particular with this whole month is with the sunspot activity coming around, you'll notice that the prominences are a lot smaller around the edge. There are no big or long extended prominences out off the sun's limb. I don't know why. I don't know if there's an actual relationship there, but they just seem to have gone away during this time of higher sunspot activity. On the next one was the 24th, the very next day. And getting a little closer to the edge, a little out of line there. I didn't quite get this lined up as much. It looks a little higher. 776 is ready to roll away. And up here was a very short-lived 12777 that had two nice little sunspots in it, but it seemed to last about one day, and that was it, and it was gone. Now, on the 20th of the month, we had this was great. This was a real nice start to the end of October for sure. This nice grouping of 778 and 779. At this point, 778 is the lower region here. 779 is just a small sunspot up to the upper left of that. And on the H alpha side, you'll notice we have a nice row of filaments coming across the surface. And you'll see as we go on here, they will extend almost right across the surface of the sun. So even though there's not a lot in white light sometime, there's always something in H alpha for sure. Now, as those two sunspots, 778 and 79, came a little closer to the west limb on the 30th, you can see that 779 has got a lot bigger, but still, not as big as what's coming for sure. And the filaments have gone almost the entire way, that row of filaments across the surface from within a few degrees of either side. And actually, it may be linked to that filament at the top on the left on the northeast side, but I couldn't get enough definition to show that. Through all these, you've noticed that for sure that the graph on the bottom, the X-ray graph, has been much more active than it has in the past, and is holding itself in the 10 to the -6 to -7 area and peaking into the -5s, which is indicative of a new cycle and new spots coming along. The 30th was a rather cloudy day, and you can see that 1278-79 is barely visible, and the surface of the sun in H alpha is very bland and not very grainy at all. And that's just what that crappy sky does when it starts to turn real hazy. Something we didn't experience much of this summer, because this summer there was a lot of clear weather, a lot of really clear air with no jet contrails, no vapor, no nothing. It was fantastic. Then next, 781 came along. On the 4th was the first day, 4th of November was the first day I was able to observe it and image it. And it's looking like a beautiful spot with lots of small sunspots within inside it. And it has turned out absolutely wonderful, and is my background behind me in that you've seen this evening. It's wonderful. We haven't had a sunspot like that in probably 3 or 4 years. It's been that populated with spots. And as it moves across the solar face, this day here also was a little bit hazy, so did not get as much detailed. And here is an inset of the actual spot on a really good day with really clear air. And that is the 29th of, the 8th. Looked at the time instead of the, on the 8th of November, just a couple of days ago. And now, unfortunately, it has started to diminish, started to decay. This is the 11th today, the 9th. The 9th. And over to the 11th today. Most of those spots are now absolutely gone. This was an early morning picture by put on spaceweather.com, and I couldn't get it. There was no clear sky this morning, and so that was pretty well it for my observing. And so I decided to end my report with this picture of Mars that I took on the banners in the way. Was it the 6th, I think? And then I came home from shopping this afternoon. We had to get some groceries, and lo and behold, it was clear. Kind of clear. A little cloudy on the H alpha side, got a little clearer spot on the white light, and we have 12,782 coming into view on the southeast limb, and it looks like another really good sunspot coming. I managed to catch it just prior to this peak of the C 2.6 flare that it had, and it's been a happy month. And that's about it for my report. Thank you all.
That's excellent, Hank. I didn't get to see the sun today. I saw it yesterday down at the waterfront just as it was slipping into a cloud. Of course.
That's a pain in the neck, but sometimes it does look very dramatic when it's going into the clouds as well.
Yeah.
Very encouraging, Hank. Thanks a lot.
Well, thank you.
Okay, we have Kevin and Cal, 2020 member gallery.
Okay, a quick bit of background on this is we are watching the British Astronomical Association annual general meeting, and they had highlights of members' images from the year. So I thought, hey, that's a great idea for us. Can we see the slide presentation? Yep, okay. So I put out a call a few weeks ago for members, you guys, to submit your best image of the year, along with a little description of why, and also some technical specs. We've gotten a bunch of submissions so far, and I'm extending the call till the end of the calendar year, so 2020, December 31st, for the rest of you to look through your archives, find one of the pictures you think is your best, send it in, and we are going to put this all together in an annual publication and archive it away as well and present it on our site so that people can see what you're doing. So to give you a quick highlight, I'm not going to read through all of these, but these are in order that they arrived. And surprise, Hank Bartlett has picked a solar image. It is a very awesome solar image, a description of what it is and why it is, and some technical specs. Steve Craig, Malcolm Park, Mark Kay, Graham Hay, Bruce Elliott. Comet Neowise seems to have been a very popular target this year. Kathy Hall, Roger Hill, and one from myself. Okay, so that is basically what we're trying to do to create a little bit, another gallery collection. And please look at your stuff in the next month and a half and send it to me, and we'll add it to the package. Thank you very much.
Thank you to all the participants so far. Those are excellent images, and I'm sure there's more out there.
Nice images and a nice layout to put them in, Kevin. Thank you.
It's very nice.
Maybe we'll print it off and sell copies in the lobby.
You have a lobby at your house?
Okay, yeah. The lobby. Okay, I just wanted to say, Kevin, that the picture with the specs beside it is very handy for people who are looking at a target thinking, what kind of settings should I use? And that could be very helpful to people.
it's always the first or second question people ask when they see any image from anybody, right?
Mhm. Okay, Bruce, did you say you had a couple of images to show? Unmute.
Yes, I can. Let me see. Okay. Are you seeing something?
Yep.
Okay. Right. So Rick had mentioned that Mercury and Venus are going to do some interesting things towards the end of this week. And I decided I'd sort of get warmed up a little bit just to make sure everything was working okay. So this image was taken, what's that? Monday? This is early in the morning, roundabout, and the 9th was Monday, I guess, Monday morning. So it was, I guess it was about 6 o'clock in the morning that I was out there. And this, I have the tripod for my camera just sitting on the front lawn of our house. We're looking towards the, I'm looking towards the southeast. This is actually the top of what used to be St. Mary's Hospital by the St. Mary's by the lake. So I was really excited that I was actually able to see Venus and Mercury. I'm not showing the moon in this picture, but it's quite a bit higher up. I'm hoping to capture it a little bit later in the week. I wasn't quite sure what this was in the upper left. It might be one of the stars in one of the constellations that are nearby. But anyway, I went to zoomed in a little bit more, and I got I think I got a fairly clear image at that point. This is the December issue of Sky News, and it's advertising what Rick was saying is going to be happening towards the end of the week. And I guess I'm picking up Venus and Mercury. I'm wondering if that star that I saw here might in fact be something like this. When I read the description in the Sky News, it said that Spica, or it would be the star Spica would be very near, will be very near this event, this conjunction. So I'm not sure if anyone has any feeling about that. I'll perhaps do a little bit more research into that to try to identify it. But that's basically all I wanted to say. And if anyone has any suggestion on how I might improve the images or to make some further, provide some further information for appreciation. Thanks very much.
Kevin says practice, 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 practice.
Mm-hmm. Yeah.
That's great, Bruce.
Well, thank you.
Thank you for sharing.
Bruce, isn't that Spica beside the letter N in moon? Is that what you were asking, or because your mouth seemed to be somewhere else?
I thought that, okay, so in this, I'm not sure if that's too far, but this in the description, this picture here, of course, is from Sky News, and in the little paragraph underneath, it mentions that Spica is nearby, but it doesn't actually point an arrow to it at this point.
So it's right by the letter N in the moon. So in the word.
Oh, is it?
Yeah.
Oh, this all right over here. Oh, okay. Oh, okay. So I don't have the moon in my picture at this point. And this, of course, is what it's going to, everything's going to move closer together in the next day or so. So I'll have another look and maybe I'll be able to see Spica. Thanks for pointing that out, Malcolm.
Okay, excellent. So we're going to open it up to the floor for chat and for a little while. But before we do that, I just want to say that our next meeting is December 9th. We're going to have Jenna Hines, who is the outreach coordinator for the RASC, who's going to give us a talk. And she's done some excellent work this year with outreach and with all of the videos that she and various people have put together and put them up on the RASC Canada YouTube channel. So if you can get a chance to go and take a look at them, I'm sure there's a couple of members in our club that's actually doing the Explore the Universe certificate and have actually viewed a couple of those videos to help them along. Plus, I also want everybody to wear something festive for our next meeting because we are coming into the Christmas season and we can be a little festive. And since we can't get together for our dinner, we're going to have some fun. So thank you everybody for coming out. Thank you to the new members of our executive and positions that are being filled. And so we're going to adjourn the regular meeting, but carry on. It's